Hey guys, welcome to this talk on permissionless modular rollup interoperability. It's a bit of a word soup, so I'm gonna kind of talk through some of the definitions there. But my name's Yorke. I work on a project called Hyperlane. It's an interoperability project. We're kind of embracing some of the ideas that I'm going to talk about in this talk. And if you have any further questions about Hyperlane or anything I talk about here, definitely reach out either on one of these links or after the talk. You can come up and ask some questions. Okay, so I'm going to get started. So first, I just wanted to define what interoperability is so we can have kind of a cogent discussion. My definition of interoperability is composability amongst dApps that are on different infrastructure. So that's like a pretty high-level definition. But what we've observed in crypto and in like the blockchain ecosystem in the past, I don't know, 10, 20 years is that dApps that are enabled by this new technology are on increasingly divergent infrastructure. And this is because they want to take advantage of new innovations, basically new advances in research that are only being deployed on kind of like new infrastructure layers, because the ability to either include those properties in existing networks like Bitcoin or Ethereum or even Cosmos or one of these kind of established networks with network effects just becomes a political battle. You have to lobby, and you have to get your precompiles included, and you have to ask for a hard fork to get the feature your application wants. And at some critical point in network's life cycle, it stops being able to just include everything that people are asking for, because there's obviously trade-offs here. So the idea behind the modular blockchain thesis is we want to allow applications to express the types of trade-offs that they make at every layer of their stack. And I think a lot of people, the modular blockchain thesis is a very loaded term. I think it comes with a lot of different associations and assumptions. Because we're at an Ethereum conference, I'm going to talk about kind of the Ethereum rollup-centric roadmap and what that means in like this modular blockchain thesis context. This graphic over here is taken from ZK Sync's website. This is kind of like what they think the future of, their rollup architecture is going to look like for application developers. And you can see that it's very complicated. There's it looks pretty complicated. So we need to come up with a way for developers to interface with this stuff that is not so overwhelming for people to understand. But yeah, just to summarize, I guess, as we increase the complexity of the infrastructure layers and their implementations, becomes harder and harder for dApp developers to grok this stuff and to evaluate the trade-off space of should I be using Celestia as my data availability layer, or should I be using Ethereum, or should I be using EigenDA, right? These things are very nuanced. So we have to just come up with the right interfaces for people to express this. So like I said, I'm going to focus on kind of the Ethereum rollup-centric view of this modular blockchain thesis. And in case you guys aren't aware, Ethereum and the Ethereum research community and ecosystem has kind of galvanized around rollup-centric scaling roadmap. This has been kind of what the core devs have been working on for the past couple of years, basically transitioning Ethereum to be this base layer for this rollup-centric future, for the ability for us to get increased scalability properties. So basically like transaction throughput, right? We don't want to make the L1 prohibitively hard for people to run. We want it to like maintain some of these like network effects that it already has. So we can't make super drastic changes, but we can make a change like EIP 4844, which enables some innovation to happen on a layer above without requiring basically like a lot of controversial protocol changes, which might have a big impact on the existing network effects and stakeholders in the Ethereum L1. So this is kind of where we are today. This 4844, you've probably seen it on Twitter. Basically makes rollups able to use Ethereum as their data availability layer for way cheaper. That's like kind of the super high level takeaway. And what we're seeing as Ethereum kind of moves in the direction of this rollup-centric roadmap is dApp developers are actually adopting these new architectures. So both of these graphics are taken from a website called L2Beat. Basically like visualizes rollup activity. Definitely check it out. But you'll see pretty recently actually the aggregate amount of activity on these L2s has kind of superseded the activity on the Ethereum L1. If we're using kind of transaction throughput as a metric for activity. And if we look at kind of DeFi TVL, basically like options protocols have exploded on Arbitrum. You guys have probably heard of GMX. They're killing it right now on Arbitrum. And yeah, application developers are starting to adopt these rollups. They see the benefits of the lower fee environment for their users, and they see the performance benefits of having these like more centralized sequencers, and they realize it's a way for them to differentiate from their competition, and so they're migrating to these new layer 2s, which is exciting, right? We're actually seeing a lot of innovation happen in real time. But there's kind of a problem that comes with this innovation, and that is that the ability for all these applications, which are now deploying on these new rollups, no longer have the kind of like atomic composability that they had on Ethereum L1. And if you think about kind of like DeFi Summer and like the ethos of Ethereum as this like generalized execution environment, a lot of people believe that like this property of atomic composability is the reason that Ethereum is like such a valuable developer primitive, and that we can deploy smart contracts that leverage each other's network effects rather than having to like bootstrap our own network effects within kind of some like siloed application. This is like the idea behind Lens, right? Instead of like, if you want to compete with Facebook, you have to go and build your own social media company and like get people to come on board. With Lens or with any of these like smart contract platforms, you can leverage these existing network effects without being competitive. You can be cooperative. But when these applications are on these L2s, there's kind of this fragmentation that's been happening. And there's all these different types of interoperability now. There's no longer just this like simple atomic composability. There's deposits and withdrawals from L1 to L2. There's this like asset bridging that's happening between rollups to share liquidity and to kind of like balance demand across the different rollup environments. And there's also general message passing between rollups. So this is like asynchronous composability, basically having like smart contracts interact with each other in an asynchronous manner. There are some attempts, some recent attempts and like working groups to address some of this fragmentation. I noted one of the EIPs here. But generally, it's really hard as an application developer to look at this stuff and like know what you should be doing. So yeah, just kind of highlighting that with this, new rollup future, dApp developers have a much harder task to understand what interfaces they should be using. This interoperability, especially between these like heterogeneous environments, that is kind of being enabled by this rollup future, unlocks like new forms of innovation that actually weren't possible on Ethereum L1. So not only are we getting the scaling benefits, but we're also seeing new forms of applications that are only possible because we have an application that's leveraging properties of some infrastructure, like multiple infrastructure layers. So there was actually this really cool article that A16Z Crypto's research team just released. They've been doing a bunch of like research into auction theory, on-chain auctions, like verifiable, fair auctions. And they built this cross-chain application which leverages Aztec Connect, which is like a privacy L2, to do a sealed bid auction, which is kind of like this thing that a bunch of people have been trying to implement, but it's like really hard to implement, and like maybe it's a solution to MEV, but we're not sure. But yeah, just wanted to, again, to highlight, like, not only are we getting scaling and we're getting, applications can now basically like do things that they couldn't before, which is also really exciting. A lot of people are like light client maximalists, and this is an idea that like somewhat comes from the Cosmos ecosystem. So they believe that like interoperability between these heterogeneous environments should only use what's called native verification, which is basically like you have this thing called a light client, and it's basically syncing on-chain with some other chain's consensus. So it's consuming the headers that are being produced by some other chain, and it's verifying them locally. And so this is called like native verification. But the problem with this in our like, super fragmented rollup world is first of all, there's not light client implementations for most of these things. But second of all, like the implementations are very specific to the state model. And so in this like modular blockchain thesis, we want to allow applications to express their preferences at every layer. With something like Cosmos, there's actually a lot of baked-in assumptions that enable IBC, and some of those are basically like, you have to use the same consensus model, you have to have the same state model, and this allows you to have this, universal light client interoperability. But where we are in Ethereum, this basically is impractical, especially with the ETH2, the size of the ETH2 validator set. A light client for the ETH2 validator set is like extremely, extremely expensive to run on chain, basically like prohibitively expensive. So we need to turn to alternatives. People are doing some really cool research stuff on like ZK, on the ZK side of things. I'm a little further away from that, but like people are working towards solving this like ETH2 light client problem, but it's like still very much in the research stages. Okay, so we want modular interoperability for application developers in this like rollup-centric world. We need to separate the transport layer and the application layer. So this is kind of where we depart from maybe like what the Cosmos model is, where there's kind of like a bit of a verticalized stack. And yeah, the basic premise is like dApp developers should just understand the interface to the application layer. This is going to be a simple like send and receive, or in this case, a dispatch and handle interface that should be consistent across all these rollups, all these like different execution environments. We can have a consistent interface. That's possible. And if we do this, we don't need like to maintain all these different implementations. We can just have a spec. I mean, maybe we want like some diversity of implementation, but generally, this makes the dApp developer's life a little easier, because now they don't need to understand, okay, L1 to L2 withdrawal versus L2 to L2, generic message passing versus asset bridging between L2 and some Cosmos chain. Like all those right now are completely different applications with their own set of interfaces. So you like the complexity of some of these code bases is just like crazy. Because you have to special case basically like every single pair of chains that you're connected to. You want this interoperability. We also want to allow dApp developers, or maybe some delegate that dApp developers select, to express their security preferences and their risk tolerances. So as a recipient application, when you're getting some inbound intent for interoperability between some other chain, or from some other chain, or some other rollup, you want to basically specify through some consistent interface, like what is the security model. We can have like basically the equivalent of token lists. Like Uniswap has a list of token lists. We can have like a community governed list of security models for all these different channels that developers can just opt into, have a consistent interface to, but they don't need to all implement themselves these verification mechanisms from all these, I guess, heterogeneous environments. There will be some kind of like, canonical set of verification mechanisms. Maybe some are like clients, maybe some are like these optimistic verification mechanisms. Some are proof of stake sort of systems. And application developers don't need to like necessarily understand all of the transport layer stuff that's happening in between. They just have this like configuration layer for security and a simple like dispatch and handle interface. They get this like interoperability across all these environments. So at Hyperlane, we call this sovereign consensus. It's kind of like a funny name. But yeah, the cool thing about this is like applications, whenever these new verification mechanisms that are coming out of the research community become available, they can just like change their configuration. They don't need to go in and like re-architect their entire system to accommodate some new light client implementation or something like that. They just say, oh, I'm going to set my interchain security module to this new light client module. So the way this is, I guess, modular in the Hyperlane architecture is we basically allow anyone to deploy this. It's a protocol, but it's also basically just this interface of like dispatch and handle, configuration layer, and if you're spinning up your own rollup, which is kind of the idea of a bunch of these like rollup as a service projects, like you've probably seen the Optimism, the OP stack. Celestia has their like Rollmint, Rollkit thing. Arbitrum now has something like this. A lot of new projects kind of competing on this like rollup as a service model. People want like app-specific rollups because they get all these scaling benefits and like they get more fee revenue. So you don't want to have to go out and like lobby some validator set or some bridge. Like you don't want to have to go to Wormhole and say like, hey, please support my chain and bridge here so that I can like leverage existing network effects from these other chains. You can just deploy this protocol yourself and you get all the benefits of inbound security. If you want other applications to basically like compose with you on your outbound communication, they need to opt into that. So they need to kind of configure some interchain security module which knows how to verify your rollup or your chain. You can go and deploy that for them. But yeah, this is the basic idea. You don't have to go and do BD to like get interoperability anymore. You now have these modular systems where you can just, as an application developer, like be chain agnostic, not bake in so many assumptions when you're doing your like initial architecture or like design or deployment, but rather be like super extensible to all these new rollups, new verification models. And yeah, I encourage you guys, if you want to like spin up your own rollup this week, you can try deploying Hyperlane on it and sending messages between our existing deployments. You should hop in our Discord, tell us about what you deploy. We're super curious what people are building in these like cross-chain architectures. I think my time's up, but yeah, definitely come down and ask questions if you have any. And yeah, thanks so much for my time.